Okay, in this case, we are told as the frequency of the circuit is either raised above or lowered below the resonant frequency, what happens to the impedance of the circuit? Does it always increase, or increases only for lowering the frequency, or increases only for raising the frequency? Okay, the answer is it always increases, because remember, for the resonant frequency, we should have the lowest impedance. So if we change the frequency either way, we are going to go higher than the lowest frequency. Remember the diagram. Here's your diagram. So if we lower the frequency, we are increasing the impedance this way. If we increase the frequency, we are increasing the impedance this way. Now, in this question, the AC circuit is being driven at its resonant frequency. Compare the maximum voltage across the capacitor with the maximum voltage across the inductor. Now remember, at the resonant frequency, XL is equal to XC. And remember that VC max is equal to I max times XC. And VL max is I max XL. So saying that XL is equal to XC is the same as saying that VC max is equal to VL max. So my answer is this. And it does not depend on R, of course. At the resonant frequency, which of the following is true? The current leads the generator, the current lags the generator, or is it in phase? Okay, look at your phasor diagram. At the resonant frequency, VL is equal to VC, so Vgen is parallel to VR, with phi equal to 0. That means it is in phase. I is in phase with the generator. Your radio is tuned to FM 96.1 megahertz, and you want to change it to 105.9. Which of the following will work? Increase the capacitance, decrease the capacitance? Okay, here we need to remember the expression for the resonant frequency. I'm going to go back in slides here. Okay, that's the expression. 1 over 2 pi square root of LC. So if I need an increased frequency, I need to increase F. I obviously, since C is in the denominator, I need to decrease C. So I need to decrease the capacitance. Of course, I can do the same thing by decreasing L. But usually, it's more practical or easier to decrease C, and that's the way we do our tuning for most of our devices, TVs, radios, etc. Our tuning is done by changing the capacitance value of a capacitor. Okay, in this case, we are going to calculate something. We are given the circuit. We are told that the resistance is 2 ohms, the inductance is 0.3 microhenries, and we have a variable capacitance. Actually, the symbol for variable capacitance will have an arrow on it to tell us that it changes. And we want to listen to 96.1 megahertz. And we are asked what value of C we need. Remember the expression that we just discussed? F0 is 1 over 2 pi square root of LC. So in this case, we are solving for C. So we need to square both ends. F0 squared is going to be equal 1 over 4 pi squared LC. And we solve for C, then my C is equal 1 over 4 pi squared L times F naught squared. And we need to plug in all the quantities that we know with the right units. So 4 pi squared, for L it's going to be 0.3 times 10 to the minus 6 henries, and for F naught is going to be 96.1 times 10 to the 6 hertz, and that's going to be squared. This comes out, if you do the calculation, as 9.1 10 to the minus 12 farads. It's a very small capacitance.